Hello everyone, welcome back. Today, we're building an ESP32 wireless joystick game controller. The ESP32 uses Bluetooth HID to work as a wireless keyboard, so no extra software is needed. We need the following components: ESP32 DEV kit board, 2 joystick modules, 3.3 volt battery, A to B USB cable, jumper wire and nuts, bolts and screws. Take a piece of cardboard, draw the design of a gaming pad on it, and cut it out. Then, make a hole to attach the joystick. Create a second piece as well, making 2 holes in it for the fitting. Now let's understand the connection. For the left joystick, connect the VRX pin to GPIO34 and the VRE pin to GPIO35. Connect the VCC pin to 3.3 volts and the GND pin to the ESP32 ground. For the right joystick, connect the VRX pin to GPIO32 and the VRE pin to GPIO33. Again, connect VCC to 3.3 volts and GND to the common ground. If you want to use the joystick push buttons, connect the left joystick SW pin to GPIO27 and the right joystick SW pin to GPIO26. Once the ESP32 is paired with your computer, every joystick movement is transmitted wirelessly through Bluetooth. Finally, power the ESP32 using a 5-volt battery connected to the VIN or 5V pin and GND. After completing these connections, the hardware setup is ready. The left joystick controls the W, A, S, and D keys. Move left A, move right D, move up S, move down W. The right joystick controls the arrow keys. Left arrow, right arrow, up arrow, down arrow. This wireless game controller can be used for browser games, Subway Surfers, hill climb racing, retro games, arcade games. Now let's talk about the coding. The project is programmed using the Arduino IDE. We use the ESP32 BLE keyboard library, which allows the ESP32 to behave like a Bluetooth keyboard. The code continuously reads the analog values from both joystick modules. It compares these values with predefined threshold values to detect the joystick direction. Whenever the joystick moves, the ESP32 sends the corresponding keyboard key through Bluetooth. The ESP32 continuously reads the analog values from both joystick modules through its ADC pins. The program compares these values with predefined threshold values to determine the direction in which each joystick is being moved.